machines interact like people, and bodies can be rebuilt from scratch. How will we wage war, fuel our need for power, commute to space? What technological leaps will most change the world in the next 50 years?
Capturing the power of the sun, invisible soldiers, elevators to space.
See how scientists today are making visions of tomorrow real. Physicist and futurist Michio Kaku will be your guide. The future is closer than you think.
It all starts now with the world.
2057. The Earth faces a crisis. Fossil fuels millions of years in the making are finally running out. And other sources have not made up the shortfall. Across the globe, political conflict looms. Tethered 250 miles above the ocean is one of Earth's last hopes: an international research station. For 5 years, a team of 40 scientists has been trying to develop more efficient ways of capturing solar energy. But billions of dollars later, they've produced no breakthroughs. They have all been pulled from the station, except two: an American chemist and his Chinese colleague. Within weeks, they too will be sent home and the project abandoned.
Shade.
Producing countries have stalled.
Morning, Bob.
Morning, the chow. Any good news?
Not yet.
Coffee? Perk you up?
No thanks. I've almost finished prepping another panel. Should be ready to go in a couple of minutes.
Sounds good. I'll be there in a minute.
Up next. First it was gasoline rationing.
You give me coffee with no coffee?
I'm sorry, we've run out.
Well, then order some more.
I'm sorry, no more food orders. We have enough supplies until station shutdown.
Great.
In a last-ditch effort to find a solution to the energy crisis, the scientists are experimenting with ways to improve solar panels by altering their chemical composition. Solar technology has been around for decades, but it could be much more efficient. The test panels are coated with a new formula, then exposed to the sun in the hope that they can create a better, affordable solar panel.
Harnessing solar energy is still considered too expensive, too inefficient to be a serious source of power. So why are scientists and oil companies spending millions of dollars investing in solar technology? Well, I'll tell you why. It's because sunlight is clean, it's safe, and oh yeah, it's also limitless. Now, get your head around this fact. Every second of every day, the sun produces billions of times more energy than is consumed by the entire planet. The trick is catching it.
TUV Rhineland in Cologne, Germany is the largest photovoltaic test center in the world. 70% of all solar panels are tested here for efficiency and durability. Most of the panels are made of silicon, an element that absorbs light and converts it to energy. But silicon panels have a drawback. Although sunlight contains a wide range of light, from ultraviolet to visible to infrared, silicon absorbs mainly infrared light. The rest of the sun's energy is lost as heat. Scientists at TUV have spent years testing other types of cells under the world's largest artificial sun. The standard efficiency for commercial panels is 14 to 18%. Some prototypes in early development could double that. But to compete with oil or coal, solar panels need an efficiency of 50% or more. Our best hope is to find a completely new material. And at the University of Utrecht in the Netherlands, Daniel van Malkoberg is trying to create one. In a vacuum chamber, He heats extremely conductive materials like cadmium and selenium to 570 degrees Fahrenheit. At this extreme heat, the molecules rearrange themselves into crystal lattices called nanocrystals. His solution contains tiny crystals so small you could line up 3 million across your fingernail. But the most surprising transformation is visible only under ultraviolet light. The light-absorbing properties of the nanocrystals have changed. Van Malkelberg and other researchers have created the holy grail of solar power. Substances that absorb light across the entire spectrum. Combined in a single solar cell, they would be nearly 5 times more efficient than today's solar panels. But there's a hitch. When scientists apply the tiny nanocrystals to a surface, it's difficult to arrange them in a regular pattern.
Wat we nodig hebben voor een goede zonnecel.
What we need for a good solar cell is an ordered hexagonal structure of these quantum dots, with a strong interconnection between them, and almost no defects so the energy can flow well.
Makkelijk doorheen de vaste stof bewegen.
Researchers have spent years developing techniques to align the nanocrystals in a grid without defects. Van Malkelberg uses one of the most powerful microscopes in existence to visualize the result. This image, magnified 100 million times, shows they are close to creating a lattice of nanocrystals with few defects. The connections between the nanocrystals still need to be strengthened, but one day we may have a solar panel that is 80% efficient in capturing solar energy. Oil rigs will be replaced by solar farms. And if you covered your roof with solar panels, you could power your home and still sell 4 times as much electricity back to the grid. On the space station, the latest test results are in. The scientists have high hopes for their new formula.
With time and patience, the mulberry leaf becomes a silk gown.
Confucius?
Try again.
Chairman Mao?
Chinese proverb.
That was my next guess. I'm sorry. I'm patient, but we're running out of time on this. Let me take over.
I'll clean the transmitter. Oh, Paula should be here soon to check the photovoltaic generator.
What about the new batch of test fluids we ordered?
She's bringing them up.
Finally, some good news.
The fluids or Paula?
The space station is about to receive a visitor. By elevator. It sounds improbable, but NASA engineers are already designing one. (2057). The worldwide energy crisis is worsening. On an international space station, scientists are racing to create a more efficient solar panel. This is one of the last scheduled visits a technician will take to repair the space station. In 3 weeks, it will be shut down.
Hello, Paula. How are you today?
Fine. How about a little bit more air conditioning?
Sorry, we're conserving energy.
Great. What's our travel time?
2 hours, 23 minutes. Get ready for takeoff.
Ready when you are.
3, 2, 1.
In the fairy tale Jack and the Beanstalk, a young boy climbs a beanstalk into the sky and reaches the clouds. Now, the 21st century version of this is called the space elevator. And oh yeah, it is physically possible. Now, amazing developments in nanotechnology may mean that in 50 years, a Sunday picnic in outer space may not be a fantasy.
Dreaming the impossible is not new in the New Mexico desert. This is Los Alamos, birthplace of the atomic bomb. Now, physicist Brad Edwards dreams of riding an elevator into space.
I started on a space elevator about 7-8 years ago when I saw a statement saying it couldn't be done. And for a physicist working on advanced concepts, that's red flag to a bull kind of thing.
Edwards, a former designer of Los Alamos satellites, wants to make space travel cheap and safe.
Rockets right now are exciting because there's danger, there's flame. We don't want that. We want it to be boring. So you get on, you're not thinking about whether you're going to die. You're thinking about, I'm going to go to space. I'm going to get there. When I get there, I'm going to do this. That's what we want.
The idea of a space elevator is not new. But Edwards is the first to work out a practical design. A ribbon will extend 62,000 miles into space. A counterweight at the end will keep it taut through centrifugal force. An elevator car will climb 250 miles to a space station. By 2057, the trip could take just half an hour. It sounds crazy, but Edwards is already working out the nuts and bolts. He plans to anchor the ribbon on a former oil rig platform in the ocean. To minimize weather hazards, he's analyzed lightning data and found a quiet spot in the Pacific with few thunderstorms or hurricanes. And to lift the space elevator, a ground-based laser will beam high-intensity light at solar panels on the elevator car. Many challenges remain. What about orbital debris damaging the ribbon? Or radiation harming us in flight? Edwards believes that current technology can solve every problem except one.
We need to make the high-strength materials. We need to make those into a ribbon. Right now, steel's not strong enough. Kevlar's not strong enough. No material that we have is strong enough other than the carbon nanotubes.
Los Alamos scientist Yuntian Zhu may have a solution. He's working with a remarkable new material that could be used for the space elevator's cable. It is 10 times lighter and 100 times stronger than steel. It's called a carbon nanotube. On a molecular level, it looks like a tubular honeycomb. It's made from the same material as coal and diamonds. The surface of this piece of carbon contains nanotubes. To see them, he uses a powerful scanning electron microscope. It took him just an hour to fabricate a nanotube. But it is so thin that to prove he had done it, took 12 hours and 230 photographs. Enlarged 50,000 times to the width of a hair, an image of a nanotube less than 2 inches long eventually circled the room. Now the challenge is to find a way to transform these tiny fragments into workable fibers. If researchers succeed, a carbon nanotube space ribbon may finally make space travel routine, opening the way for the construction of research labs, hotels, offices, and even entire colonies. Edwards believes that in less than 50 years, tens of thousands of travelers will be riding a space elevator.
It'll be tourists. It'll be more general public. In addition to workers, people going up for business, scientists going up for studies. It's a very realistic scenario.
A world based on energy-hungry technology needs fuel sources beyond oil. How about a man-made sun or ice from the bottom of the sea? Two weeks before shutdown, solar panel experiments aboard the space station take an unexpected turn.
What happened?
I'm not sure. It seems to be acting up again.
The computer is fine. I just checked it yesterday.
Then why did it spike?
I'll scan the drives again. I'll be right back.
Hello, Dr. Wang.
Secretary Luo, what can I do for you, sir?
Our base station informs me you had pretty impressive results.
Actually, sir, it's a false alarm. We're checking the equipment.
Dr. Wang, when you do get a breakthrough, I want the data first.
But that would be a breach of space law. And besides, Dr. Sanders...
Dr. Wang, you're an officer of the Chinese Army, and you will do as you're ordered.
Due to the worldwide energy crisis, the United States and China have entered a third round of emergency talks on Central Asian gas and oil supplies. The European Union will mediate. Experts speculate the U.S. may be forced to tap into its strategic reserves.
After the last oil crisis, the United States needed an energy insurance policy. So it created the Strategic Oil Reserve, consisting of hundreds of millions of barrels of oil, enough to run the entire country for 60 days. Great. But what happens when the world's usable oil supply completely runs out sometime in the next 50 years? What then? That's why researchers are focusing on solar power. Other researchers go farther. They want to create their own sun.
Sunlight starts with a bang. When two hydrogen atoms collide, they fuse to create a helium atom and release intense energy. The process is called nuclear fusion. If we could recreate that reaction, we'd never have to drill for another barrel of oil. But creating fusion is not easy.
Die Schwierigkeit des Fusionsfeuer auf die Erde zu...
The difficulty of reproducing fusion on Earth is like trying to light wet matches. It's a very complicated task. But we've made real progress in the last couple of decades.
At Germany's Max Planck Institute, scientists are using microwaves, electricity, and high particle beams to generate cosmic heat inside a test reactor. The chamber would incinerate, if not for a magnetic field that keeps superheated atoms from hitting the walls. Under enormous pressure and at temperatures over 100 million degrees, the hydrogen atoms are fusing in a superheated gas. A single gram of it would set free the same amount of energy as 11 tons of coal. But the superheated gas cools down too quickly. These scientists can only recover about a third of the energy they put into the system. The potential is great, but a viable fusion reactor may be 50 years off or more. So scientists are designing ingenious methods to tap renewable energy. Huge, super efficient windmills on land and vast wind farms far offshore. Intelligent buoys that capture the energy of waves and tides. Underwater turbines that harness the power of local rivers. And farm-grown biomass to create fuels such as ethanol or biodiesel. If these alternate energy sources don't produce enough, there is another fossil fuel we could turn to in a pinch. It lies beneath the ocean. When organic particles in the sediment decay, they create methane gas. Under intensely high pressure and near freezing temperatures, the gas combines with water and is encased in ice. It's called a gas hydrate. And this ice burns just like coal. Scientists estimate that gas hydrates worldwide exceed the total reserves of oil, gas, and coal combined. The challenge is extracting it. You would think that a diving robot with remote control arms and cameras would do the trick. But it's not that easy. When the robot heads to the surface, the water pressure drops, the temperature rises, and the ice melts. The gas hydrate escapes. But even if we could extract it, gas hydrates pose another problem. Burning methane releases carbon dioxide and accelerates global warming. Aboard the space station, scientists are still hoping for a last-minute breakthrough.
Hello, Paula.
Hi, Bob. How goes it?
Yeah, you know, still plugging away.
Maybe this'll help.
My coffee. Thank you. You're the best. Hey, besides the photovoltaic generator, we just found out we're having problems with the steering element on the laser beam.
Yeah, sorry, but I have to stick to my work order. No extras because of the shutdown.
You think maybe you can do it off the record?
In 2057, competition for natural resources could lead the world's most powerful nations into conflict.
Authorized to proceed.
Unless science can provide a way out.
You have exactly 4 hours.
In 2057, oil supplies are running low. Now, a summer heat wave deepens the crisis. Hospitals in Beijing and Shanghai are running on emergency power. Gas stations have lines half a mile long. China's leaders begin planning for the worst.
What do you suggest, Admiral?
Take what's rightfully ours. Occupy the Central Asian oil fields.
Not yet. That'll mean all-out war. I suggest more indirect action.
Such as?
Let our friends in Central Asia deal with this situation.
You don't need a crystal ball to see that the superpowers of the future will be the United States and China. And there's an excellent chance that they'll be on friendly terms with one another. But consider this fact. The Chinese economy is growing exponentially, and so is its demand for energy. One estimate is that China will need to build 4 middle-level power plants per week for the next 50 years just to keep up with energy demands. So it's not too difficult to see that in the future, these superpowers will be competing fiercely for markets, natural resources, and most importantly, oil.
As you know, several strategic gas and oil pipelines in Kazakhstan were seized last night. That means that delivery of our new supplies is now blocked.
Mr. President, my team at National Security is putting together a full report. In the meantime, Dr. Fleming has an update on our energy status.
Current supplies are good for 8 to 10 weeks, after which we'll have to tap into the strategic reserves. Either way, further electricity rationing seems inevitable, as do car-free weekends.
Not exactly a catchy re-election slogan.
Sir, do we know who's behind the raids on the pipelines?
The CIA is still investigating.
Sir, the military is operating under the assumption China staged the whole thing.
That's entirely plausible, but we must proceed with caution until we've established all the facts. No overt military action.
May I suggest we send the surveillance and acquisition platoon from our Japanese base?
Authorized to proceed.
heavily armed masked bands took control of gas and oil pipelines in the troubled regions west of China. The U.S. government has strongly condemned their actions. We'll be back with more details after a short break.
You're right. The computer's not broken. But what caused that 83% spike?
No idea. My data got corrupted when the structure fell apart.
Let's rerun that last test. See what happens. Okay?
Okay, I'll see you guys.
Wait, let me give you a hand. Photo generator running okay?
Good as new.
Laser?
What can I say? I'm a hero.
I hope I didn't waste your time. With the shutdown and everything.
Can't quit on me now. The mechanics are taking bets on you guys.
What?
Yeah.
What kind of odds they have on us?
Hi. But I like long shots.
X-rays, penicillin, Velcro. Sometimes the greatest scientific discoveries happen by chance.
I think I know what happened.
What?
The neutralizer interacted with the test fluids and created a new molecular structure.
You think that's what happened?
Let's add one drop at a time.
You got it.
The cross-contamination of fluids may have created a more efficient molecule. But can they reproduce their results?
Did it?
Wait. Why didn't it fall apart this time?
Good question.
We needed some molecular properties and quantum efficiency.
I'll run it through the analyzer. We should have the data in a few hours.
That was fast.
Big Brother's watching.
Well, you go talk to them. I'm sure I'm gonna get a phone call myself.
Hello, Li Chao.
So glad it's you. Where are you?
In a hotel room.
What's going on?
Don't worry. Your wife is fine. A situation that could change very, very quickly.
You'll get the data first.
That will no longer be sufficient. The Americans cannot have it at all.
But Dr. Sanders is working on it now.
Then you have to figure out a way to destroy it. You have exactly 4 hours.
Mr. President, I request permission to put all our forces in Central Asia on standby.
Permission granted.
With global tension on the rise, special forces will be activated, wearing flexible body armor that turns bulletproof on impact and even makes them invisible.
President, we have some exciting news. The Solaris team has discovered a substance which has the capacity to transform more than 80% of sunlight into electricity.
Congratulations. Well done.
Mr. President, there is a problem, though, sir. We are now positive that Beijing was behind the attacks on our Central Asian oil supplies. But China cannot be trusted.
What do you suggest?
Well,
We
Mr.
keep the
President,
discovery to ourselves.
How?
We make the Chinese scientist a very generous offer.
Beijing will go ballistic if they find out.
Let's hope not, sir.
The bottom line is we need those pipelines back.
Mr. President, I request permission to put all our forces in Central Asia on standby. I'd also like to authorize additional reconnaissance flights and deploy special forces near the pipelines.
Permission granted.
I'm a scientist, but I was once a soldier in the United States infantry. And the Army drills into us one fundamental fact. It takes humans, not machines, to take and hold territory. This means that we will have robots and drones on the battlefield, but they'll be useless without their human controllers.
To keep the soldier of the future alive on the battlefield, engineers are focusing not just on weaponry, but on smart armor. At the Soldier Systems Center in Massachusetts, researchers are guiding the development of this armor. It will be soft, comfortable, lightweight. But the instant it is struck by a bullet, it becomes impenetrable. MIT researcher Stephen Samuhus is developing a material to create the new armor. What makes it special is its ability to change properties. To demonstrate, Samuhus uses iron shavings suspended in oil. When placed near a magnetic field, the substance stiffens. When removed, it relaxes.
So this special liquid, which is a magnetorheological liquid, in the absence of a magnetic field, has something in the consistency like a runny yogurt. But in the application of a magnetic field, it becomes the consistency of something like peanut butter. It has a yield stress it's very difficult to push through. This lends itself quite well to perhaps making a dynamic body armor for soldiers, something which is soft and pliable and adheres to the contours of a soldier's shape when not in use. But in the incidence of a blunt object or a bullet, it can become stiff as a board.
Future smart armor will also preserve the life of a wounded soldier on the battlefield. Special polymers will act like artificial muscles. Each molecule will expand or contract when needed to provide CPR to a wounded soldier. Vital signs and whereabouts will be transmitted to a command center which will send help. Ultimate smart armor will also allow the soldier of the future to become invisible. The secret is a photosensitive uniform. The concept is easily demonstrated with a small camera linked to a laptop. The camera photographs what's behind the soldier and relays it to the screen in front, creating the illusion nothing is there. In the future, imagine uniforms blanketed with tiny cameras linked to miniature screens on the opposite side, making the soldier invisible.
Listen, Chow, we need to talk. First off, I checked with home base and promised to send them the data ASAP.
What? Why did you do that?
That's standard procedure.
You should have spoken to me first!
Hey, Chow, what'd they say to you?
They abducted my wife.
I'm sorry.
My government is demanding the formula for themselves. Bob, you have to help me. I have less than 4 hours to send Beijing the formula and destroy the data.
I got it. We have to turn the tables on them. We send a message out to the public so China can't touch Tian.
There's no way. All our communication lines are monitored.
Wait, I have an idea. You ever heard of a message in a bottle?
Data transfer by lasers is the future of communications. And the scientists will be able to beam their discovery around the world in less than a second.
Paula Keller?
Dr. Keller, this is Hudson at the landing platform. Dr. Sanders just sent down a piece of the photo generator for repair. He said he needs it back immediately.
What are you talking about? I just fixed that yesterday.
Well, all I know is it's on its way over.
Scientists plan to use laser technology to broadcast their discovery. But there's a glitch.
We should be able to change the wavelength from energy to an 847 nanometer data beam.
What do you mean we should be able to?
I've never had to make the switch before.
Great. Let's move.
Right now, you are in the middle of a traffic jam. Not of cars, but of data. The internet is being overwhelmed. Now, fiber optic cables help to relieve this digital congestion a bit, but it's simply too expensive to wire up the entire planet. So why not use satellites to transmit vast amounts of data by laser beams? Then you could send the entire Library of Congress anywhere in the world in a matter of seconds. Or you could download a dozen Hollywood movies in a blink of an eye.
Scientists at the German Aerospace Center have a reason to stay up tonight. They're waiting for a Japanese satellite to pass overhead. Most satellites beam data such as television signals by microwave. But tonight, for the first time, scientists will try to beam data 100 times faster by laser. If tonight's experiment succeeds, someday you'll be able to share 3D images, data, and virtual worlds instantaneously across the globe. Today's torrent of information will become a tidal wave. Instead of gazing at the stars, the scientists will use this telescope to receive data. This lens, just a few inches in diameter, will capture a laser signal precisely aimed from 370 miles overhead.
Right?
To make it happen, the satellite and telescope must be in perfect sync. The telescope must adjust its position to thousandths of a degree, or the transmission will fail. The final countdown. The telescope tracks the satellite across the sky. It has the satellite in its sights. It works.
Yes, we now have the signal from the satellite. We have here a very good signal. And that is the technology that could be used in future to transmit a vast amount of data from space.
Researchers still have to overcome the challenges of air turbulence and clouds which can disrupt a laser signal. But in the future, scientists foresee scores of Zeppelins in the stratosphere that will send data around the world by laser at speeds 100 times faster than today. By 2057, it should be possible to send all the books ever written throughout the globe in mere seconds. Aboard the space station, the scientists plan to use lasers to spread the word. Because their communications are carefully monitored, they slip a message to the space station's technician. She is now the key. They're counting on her to alert the media to broadcast their news.
You got 30 seconds.
any update on the situation in Central Asia?
Not yet, sir, but there's another development.
Breaking news from space, from the Solar Research Station Solaris. Outside sources have just informed us of a major breakthrough in solar power research. We now go live to Dr. Wang and Dr. Sanders on the space station.
We've discovered a material that is so efficient it can absorb and convert 3 times as much sunlight into electricity as previous materials. Dr. Wang?
I'd like to thank my government for watching over my wife during my absence. I look forward to seeing her when I land.
And we wish to thank the leaders of our nations and the European Union for their spirit of cooperation.
To verify our discovery, we'll now send the formula via laser beam to laboratories in China and the United States, and to the major solar research centers on Earth.
Let's do it.
Ladies and gentlemen, we've just witnessed history in the making. If you've just joined us, I'll try to recap. Today, on the Solar Research Station Solaris, 2 scientists have reported a breakthrough that could revolutionize the production of fuel and solve the energy crisis that confronts the planet.
What do you think the world may look like in, say, 50 years from now?
50 years? Are you kidding? Who would predict that far into the future?
Maybe cities on Mars?
Intergalactic travel?
Another big, blue, beautiful Earth?
Here's one for you. The future belongs to those who believe in the beauty of their dreams.
Confucius?
Try again.
Another Chinese proverb?
Eleanor Roosevelt.
Was my next guess.
Yeah, right.
Will technology ever solve our looming energy crisis and save the planet? Yes, I think it will. But I wouldn't put my money on any one particular breakthrough. Rather, it's going to be an energy mix of solar, wind, hydrogen, fusion, maybe nuclear. So let's hope that we find a way. Because even if we do colonize outer space, it's always nice to have a home to come back to.
Want a taste of life in the city of the future? Or hear more from futurist Michio Kaku? Go to discovery.com/2057.
Interact in the future zone.